Welcome to this video. This is 4-4. We are talking about identifying functions as inverses by using composition. What happens if I embed one function within another function? Do they undo each other? That is the question. And this video specifically is going to focus on cubic functions and their inverse, which is cubic root functions. So let's go ahead and take a look at a couple of examples. So here in this example, we have f of x, which is x cubed minus 4, and g of x, which is the cubic root of x plus 4. And what we want to do, step one, is go ahead and check, is f of g of x, is this equal to x? So what I'm going to go ahead and do is I'm just going to drop in g of x into f of x, and g of x is the cubic root of x plus 4. Okay, I dropped that in, and now I'm gonna bring down f of x. So f of x is x cubed, so whatever x is, cubed minus 4, and now here's where I drop in the cubic root of x plus 4. Okay, now when I do this, what happens is I have a cubic root that's being cubed. Okay, so a cubic root and a cube, okay, are inverses, so they undo each other, so they cancel. If there was anything outside of the cubic root, that would not cancel, okay, but in this case, they do cancel. Man, I got something stuck in my eye. Oh, can't see. Okay, so these cancel, all right, and we're left over with x plus 4 minus 4. Okay, and this is equal to x. All right, so first condition is satisfied. Now I'll go ahead, we'll flip the script. I'll take g of x, and I'm going to drop in there f of x. Okay, so g of f of x. And what I want to do is I'm going to take my f of x function, which happens to be x cubed minus 4, Schwarberg, minus 4. Okay, and I'm going to embed that into g of x. So now g of x is the cubic root of x plus 4. Well, I don't have x. What I do have is x cubed minus 4. That's my input, okay? So I'm dropping in those range values, and I'm going to add 4. Okay, so I have to go ahead and kind of reduce this. So I have the cubic root of x cubed, because here my negative 4 and positive 4, okay, those cancel, and we have the cubic root of x cubed, which is just x. Okay, so condition 2 is satisfied. So what is our conclusion? Well, our conclusion is that since f of g of x is equal to x, which is equal to g of f of x, f of x and g of x are inverse functions. Okay? All right. So let's go ahead and look at another example. I know this one says practice. If you want to do this as practice, feel free, but I'm kind of going to give it away. This is a counter example, so I want to walk you through it. Okay, so I want to use composition to determine, okay, are these inverses? And what I get is f of g of x. Okay, so I'm going to take my g of x function, I'm going to drop it in. That is the cubic root of x minus 6. Okay, and then I'm going to drop that into f of x. And I know I got away from the color coding here. I'll color code for you. Okay, that's my x value, right? And I want this cubed. So this quantity cubed plus 6, where I'm using red for f of x and blue for g of x here. Okay? All right. So let's go ahead and look at this. Now, note that this is equal, right? Notice that I don't have it just on the interior. I have a cubic root, so I can't cancel those out. What we have, though, is the cubic root of x minus 6 times the cubic root of x minus 6 times the cubic root of x minus 6 plus 6. Now, in order for this to equal x, does this all reduce to just being, does this all just reduce to be x minus 6? And the answer is no, this does not. This does not equal x. And if you wanted to, you could go ahead and multiply all of these out, and that's some pretty nasty algebra. But here's what gives it away, is that inside my cube, inside the cube here, okay, I don't just have this. If I have all this extra stuff, right, in this case just a -6, that's not going to reduce down. These are not inverse functions, right? And when one condition fails, both conditions fail. We can say since f of g of x does not equal x, f of x and g of x are not inverse functions. Okay, and there you have it. That's determining inverse functions via composition, and this is specifically talking about cubic roots and cubic functions. Okay, so I want to go ahead and show you. Here is the response to this example. Okay, all right. I want to show you this here real quick. This says Sylvia used composition to determine whether two functions are inverse functions. Here's her conclusion. Do you agree or disagree with Sylvia, and why? Well, the first step, f of g of x is equal to x plus 3. We don't want it to equal x plus 3. We want it to equal, yeah, just x, right? You want to get out what you put in. So in this step 2 equals to x plus 3. Okay, and her conclusion is that since they're equal, they're inverse functions. Well, Sylvia, I'm sorry, and that's not right. Okay, it has to be equal to x. All right, so again, in this video, we talked about verifying inverse functions via composition, dropping one function into another, and then seeing if we got that same thing out. And in this case, it was x. Catch you next time. Peace.